I'm going to do a little demonstration of the use of a General Radio 1606B bridge to measure antenna impedance. This is the GR1606B, and it's a rather old, this is 1970s, complex impedance bridge. Okay, so first step in using the bridge, the configuration is a source, an oscillator down here, connected into the generator port of the instrument. On the detector port I've got a broadband power meter, and I've just applied a shorting plug, an end shorting plug here to the measuring port of the instrument, and we'll unlock these knobs to do an initial balance. These instruments can't read negative reactance directly, so what we'll do, because we expect that this may well give us negative reactance, I'll set the reactance dial to 200 ohms and turn the resistance dial down to 0 ohms, and we'll use these two knobs here now to create an initial balance. As you can see, it was actually balanced. So there it is there. So you see when it's way off balance, big numbers. Okay, we'll call that an initial balance. We'll lock these knobs so they don't get bumped. Now this has to be done at every frequency you make measurement on, so it could vary just a little bit even with a small change. So we've now got the instrument, so it's reading 200 ohms of reactance and 0 ohms of resistance. The important thing about this reactance dial too is that you have to divide it by the frequency in megahertz to get true ohms of reactance. Okay, so we'll take this off now and we'll substitute with the antenna. The antenna is a loaded mobile whip on a car, and we're looking at it through 4 meters of RG58. So the trick is now to balance it with these knobs. So I'm just watching here, it's coming down a bit, not doing a lot. Oh, here we go. Right, let's... Okay, I think we'll call that balanced. The reading on the dial is 440. That has to be divided by 7, and 35. So it's 35. It's on the plus side of 200, so it's going to be a positive reactance. We have to subtract the 200 from 440, so there's 240 divided by 7. So the impedance we've measured is 35 ohms plus J 240 on 7. To measure, we'd write that down. That doesn't give us the feed point impedance, that's a further calculation that needs to be done sort of offline. We'd plot that on a Smith chart usually, and then deal with the transformation of the line to work out what the feed points of the antenna is. Then we change the generator frequency and do it all over again, do the initial balance, and then we measure the antenna. And so to do a sweep of say 8 or 10 frequencies, that might take 15 minutes by the time you do it, write all the numbers down. Then there's another hour of grinding around with Smith charts and a slide rule to come up with the actual feed point impedance at those 10 points.